Okay, welcome to College Mathematics 1106 Test 2 review session. So we got 25 questions to get through. This covers chapters 9. So 9.1 through 9.3, which is all about conversions, dimensional analysis. And then chapter 10, which is all about geometry and basic surface level. So we'll do 10.1 through 10.5. So the first basically half of your test is all about dimensional analysis, the 9.1 through the 9.3. So right here, what's cool about your test is anything that you might need as far as conversion based wise, they're going to give you the table for right over here. So use that to your advantage, and it's telling you exactly everything that you need to do. So in this one, we're going from metric to metric. So 0.018 millimeters, and we're going to convert that into meters. Okay, let me go ahead and erase my blue circle real quick so that way you can see my labels. And we're going to convert that to meters. So you are going from a small value to a large value. So we are moving left, and we are moving left 3 steps, and for each step divide by 10. So we're going to take this number and divide it by 10, divide it by 10, divide it by 10. Okay, so if we go to our calculator, 0.018 divided by 10, divide by 10, and now you start to see something weird. Divide by 10. You see this little E pop up. Don't be afraid of that E. That E just means scientific notation. That E means times 10, and then this -5 right there is the power on it. So what our calculator is showing us for an answer is 1.8 times 10 to the -5. Again, this guy represented that E. But in the test, it's not going to want that. It doesn't want scientific notation. It wants the decimal. So again, all this means right here is because the power is negative, that means move the decimal to the left 5 times. So if I have 1.8, go 1, 2, 3, 4, 5. That's where the decimal is. All these extra blanks in here are all zeros. So the real answer that they want is 0.000018 meters. That's what they're looking for. So if you ever see that E on your calculator pop up, that just means scientific notation. Don't let it bother you or throw you off or anything like that. You're all good. So there's your first guy. Let's move on to the next one. Again, all this is about conversions. Sometimes it's all about moving the decimal, which is like multiplying by 10, dividing by 10. That's what the the metric system is all about. And then we got our lovely English system right here. So this one is all about going from English to metric. Cool thing is they allow you to round on this. So definitely pay attention to those blue words that you might see pop up. So taking a look at what we got here. We've got 23 centimeters, and we want to convert that into inches. Well, if we look at our little box over here, is there a relationship between inches and centimeters? Absolutely, it's right here. So this is what we call our unit fraction. We just got to make sure that we get it set up correctly. So remember in dimensional analysis, I told you in class that the label we want to get rid of goes in the denominator. So we want to get rid of centimeters. So centimeters is down in the bottom, and we want inches. So that goes in the numerator. And now that tells us how to use our fraction. So the 1 that is for the inches, the 1 actually goes in the numerator. The 2.54 for the centimeters goes in the denominator. And so all I'm going to do is go to my calculator, and I'm going to take 23 times 1 over the 2.54. Let my calculator do the work with fractions. So 23 times my fraction, which is alpha y equals, we want the first one, so that's 1 over 2.54. Hit enter, and there it is. again, the cool thing is it wants us to round to 2 decimal places. Just double checking again, make sure. Yes, hundredth. Hundredth means 2 decimals. If you didn't know what hundredth meant. So going back to our calculator, here's the hundredth. So this 5 says, hey, hundredth, go up 1. So we got 9.06 for our answer. And there it is. Again, just dimensional analysis. That's all we're doing. Converting from one form to the next. So over here, in the homework or in our problems, I never really talked about what you do with 2 labels, but really one of these labels does not matter. So, and that's the per hour part. That just means hours is going to be in the denominator. What you're really after is changing 40 miles into kilometers. So what we're looking at here is 40 miles over hours. And we want to change this into kilometers over hours. Again, like I said, you already got the hours in the denominator. We're not changing that. We're just working with the 40. Now, is there a relationship between our English miles and the metric kilometers? We look over at our chart. And yes, there is, right here. We know that 1 mile is equal to 1.6 kilometers. So again, dimensional analysis says if we want to get rid of the miles, we put it in the denominator. If we want to change to kilometers, it has to go in the numerator. So all we do is plug in the numbers that we know. The 1 for miles goes in the denominator. The 1.6 for kilometers goes in the numerator. So all we're going to do really, in essence, is take 40 times 1.6. So let's go over here. 40 times 1.6 equals 64 kilometers per hour. Done. So the hour part and the denominator really didn't matter. It's just all about changing the miles to the kilometers. Okay. Question number 4. So we want to change HA, this HA, which stands for hectare, into acres. Okay? So again, we're going from that metric system to English. And we can round to the nearest hundredth as needed. And right over here, you see the relationship. So it's no more than what we've been doing on all these other problems. We're going to take 38.1 HA, and we want to change it to acres. Again, dimensional analysis, using that unit fraction. The HA goes in the denominator because we want to get rid of it. The acres goes in the numerator. So there is 1 acre for 0.4 hectares. All right, so all we're going to do is take 38.1 times 1 over 0.4. 38.1 times alpha y equals 1 over 0.4, or 0.4 if you want to put it in that way. And there you go, 95.25. 95.25. And since it says hundredth, remember that's 2 decimal places. We don't really have to worry anything because it's already got the 2 decimal places. So 95.25, there's the answer. Pretty straightforward. Okay, the next guy. Ooh, trying to trick us on some things here. So let's take a look. So it says a swimming pool has a volume of 41,255 cubic feet. How many gallons of water does the pool hold? Okay, so hopefully we have something over here that can help us with converting cubic feet into gallons. So if we look at our chart, hey, right here, cubic feet and gallons. And then so down here there are 3 dots. Really, this is kind of like a multiple choice question where we want to know which one are we going to be working with. And so because our label is in gallons, we're going to be dealing with this bottom guy here. We don't have what is called gallons cubed and gallons squared. Gallons is volume. Okay, so that will give us our answer. So what we need to do is some dimensional analysis real quick. We're going to take the 41,255 feet cubed, or cubic feet, however you want to call it, and you're going to turn that into gallons. Okay? So we already know our dimensional analysis. We want the feet cubed in the bottom, and that's 1. And we want our gallons, which is 7.48 gallons in the numerator. So again, we'll just go to our calculator. We'll take 41,255 times the 7.48. 41,255 times the 7.48. And there's how many gallons it is. So 308,587.4 gallons. Let's see if it says anything about rounding. It says round to the nearest whole number. So that 0.4 over here says, hey 7, stay the way you are. So our final answer then, 308,587 gallons. 308,587, I believe it was 87. Let me double check. Yep, 87 gallons. And there we go. And that 308,587 would go into the blank that it was up there that I circled in green. Next question. Again, this is just like question number 1. We're going to convert from milligrams to grams. So if you look over here to a little chart, milligrams is down here, grams is up above. So we are converting from small to large, which means that we're going to be dividing by 10 3 times. So we're taking this 760 milligrams and dividing by 10, dividing by 10, dividing by 10, and that will tell us the number of grams we have. So 760 divided by 10, divided by 10, and you could have done this all in one line, divided by 10. So 0.76, as long as I use the right number. Yep, 0.76, and there's nothing up here about rounding or anything like that, so there's your final answer for that guy. Again, it's all about kind of moving the decimal. You could have just moved the decimal 3 places to the left. 1, 2, 3. 0.76. Okay, question number 7. Looks like we're doing a little bit of temperature here. And they give us the 2 formulas. You just got to make sure that you choose the correct one. Which one is it? Well, what are we given down here? We are given the Celsius. And they want us to figure out what is the Fahrenheit. So that means we're working with this guy, because we are given the Celsius, and that will kick out the Fahrenheit. So all you have to do is just plug this in the calculator. Fahrenheit is going to equal 9/5 times 25 plus 32. So go to that calculator, type in your fraction, multiply it by 25, and then add 32. So alpha y equals 9/5, scroll out to the side, parenthesis, 25, close it, plus 32. And there's our degrees Fahrenheit, 77. Let's go back. 77 degrees Fahrenheit. And there you go. It's a simple plug and chug. Plug into the formula, kick me out an answer. Okay? Don't let it throw you off. Again, oh, a little different. That was question 7, right? Did I miss one? Thought there was another one. Go back. I did miss one. Whew. That's a close one. Let me make sure that I haven't missed any others by accidentally skipping over. So let's make sure. There's work, there's work, there's work. Everything has work except for this guy. All right, so we are on number 8. Okay. So again, they give us those 2 formulas. We got to figure out what we're going to convert to. So they're giving us Fahrenheit, and we're going to Celsius. So that's this formula this time. So again, we'll take 5/9 times our Fahrenheit, which is 69, minus 32 this time. Double check that formula. Yep. So that will tell us what Celsius is. So again, just go to our calculator. We'll take the 69 minus the 32, and then we'll multiply it by the 5/9. Or you can just put it all in at the same time. 5/9 out to the side. And what was our number again? 69. 69 minus 32. Enter. And there it is. But they don't want the fraction, because if you go back and look at the directions, it says round to the nearest tenth. Tenth means 1 decimal. So we need to actually divide that out. So 185 divided by 9. So over here, since we're going 1 decimal, this is the first decimal, this is the 10th. So the 5 says, hey 5, go up. So in degrees Celsius, we are 20.6 degrees Celsius. Okay? Pretty straightforward, nothing crazy. This is the one that you better watch out for, because there's a lot of information that's going on here. Okay, so let's start with part A. I'm going to do part A in purple. And I'm going to show you a lot of information to this, probably more than what you need to be concerned with, but I want you to see how everybody gets affected by what's going on. So up here it tells you that each 5 milliliter teaspoon. So there's two things that are going on here. You're dealing with 1 teaspoon, and you know that that teaspoon is 5 milliliters. There's two different measures going on there. So one is the English, which is the teaspoon, and the other one is the metric. Both of them, 5 milliliters and 1 teaspoon, are the same. And then it's giving you some information about that teaspoon, that we have glucose, and we have that one, and phosphoric acid. So the first question is, what's going to happen if we have 2 teaspoons? In other words, we double it. Okay? So I'm going to write out some things down here that we know. 1 teaspoon. And so I don't cram that all together since I messed up writing it. 1 teaspoon, which is all about 5 milliliters, tells us that we have 1.87 glucose. That's how I spell glucose, correct? Yep. We have 5 milliliters of 1.87 Leviosa, whatever. Little Harry Potter there. Levulose. And 5 milliliters also grants us 2.22 milligrams of phosphorus, or 22.2 milligrams. And those, I think, were all grams, right? For the other guys? Yeah, grams. Grams. Almost forgot labels. Of the phosphoric. Ugh. Stupid terminology. Phosphoric. Oops. Acid. But we're going to double this now. Okay? So instead of 1 teaspoon, that means we'll have 2. So in order to have 2 teaspoons, we take this original information, and just like what we talked about, we're just doubling it. Okay? So 1 teaspoon is 5 milliliters, 5 milliliters, 5 milliliters, 1.87, 1.87, 22.2. But if we double it, that doubles everything else. Okay? So that's really what's going on in the first one. All of these 5 milliliters are no longer 5 milliliters because we doubled them, so they're 10 milliliters. The 1.87 also doubles. The 22.2 also doubles. So the 1.87 times, oops, too many 8s, times 2 gives us 3.74. So these are all now 3.74. And the 22.2 becomes 44.4. 3.74, 44.4. 44.4. And now we can answer the question up above for part A. So it wants to know there are blank milligrams of phosphoric acid in 2 teaspoons, and that would be 44.4. And now, again, they try to throw us off. They say if a bottle contains 3 ounces, find the quantity of phosphoric acid. So again, since everything's in milliliters down there, and this is in ounces, let's go ahead and change the ounces to milliliters. And right here, they give us the nice little fraction for that. So I want to take ounces, and I want to turn them into milliliters. Well, my fraction up there says 1 ounce goes on the bottom, and 30 milliliters goes on the top. So that means in 3 ounces, I have 90 milliliters. Now, here's what's going to go on. We're going to use this fact right here, 90 milliliters, and that's going to tell us what we need to do to these guys. How do I turn 10 milliliters into 90 milliliters? Multiply by 9. And if I multiply this side by 9, the other side gets multiplied by 9. That's how we figure that out. And in fact, if you wanted to figure out how many teaspoons that was, since all this is getting multiplied by 9, this guy up here also gets multiplied by 9. So in fact, you're talking about 18 teaspoons in that bottle of 3 ounces, which means that you have 90 milliliters. 90 milliliters. And, oops, wrong thing. Stop it. Always likes messing around with me. There we go. And 90 milliliters. So let's figure out what we got. So again, like I said, I'm giving you a lot more information because maybe they'll ask about one of the other ones. So we're going to take the 3.74 times 9. 74 times 9. So that's how many grams we'll have of those first two, the glucose and the leviosos, whatever, that we have. So we'll have 33.66 grams and 33.66 grams of the glucose and the leviosos. Right? Yeah. And then for the phosphoric acid, we'll take the 44.4 times 9. And there is that one. So we'll have 399.6 milligrams of the phosphoric acid. Yeah, this is all about doubling the recipe or, multiplying the recipe by 9 to make it a little bit bigger. So if we look up at our blank, what do we want? Again, we want to know about phosphoric. So that would be the 399.6 milligrams. And that's really what this one was about. A little bit of conversion in the end, but you just kind of had to look at what was going on. So in the first one, when you went from 1 tablespoon to 2 tablespoons, you doubled it. If you want to think about what really happened in the end, we basically took the original formula and we multiplied it by 18. That's really how we got to the end results that you see down there. All right, so I think that one is one of the ones that they like to try and trip you up on, but nothing too crazy. So that right there ended everything with the conversions. So questions 1 through 9 were all about the 9-1 through the 9-3. Everything that we do now from question 10 on is 10-1 through 10-5. So right up here, it's all about the complement and the supplement. So remember, complement means that it's 2 angles that add to 90 degrees, and supplement is 2 angles that add to 180 degrees. So if you want to figure out what is the complement of 5, take 90 degrees minus 5 degrees. And that gives you 85 degrees. You want to figure out what the supplement of angle 5 is, take 180 degrees minus 5 degrees. And that gives you 175 degrees. And of course the label's already there, but I just like to put in the label anyway. So there's your first question 10, which is all about, can you subtract from 90? Can you subtract from 180? Again, right here, we know that we have parallel lines. Hopefully you can recognize that these two are your parallel lines. This guy that's right here, that's your transversal. That's an E. All right, so then you're just filling things in. Again, you don't have to go in order of angle 1, then angle 2, then angle 3, and all that stuff. You can go in any order you want. Looks like there's a little bit of typos on here. We got a random V right here, and my two angles right here are out of order, so just be careful of that. So when I look up here, they tell us that in the directions, this angle right there is 101. And I like to mark my picture up, especially in geometry, because it helps me visually see what's going on. So since I know that that angle X is 101, the first angle I know right off the bat is that angle 3 is 101. And the reason why I know that is because of vertical angles. Remember in class, this is all about that vocabulary. That's what helps you out with this picture really in the end is vocabulary. And you got vertical angles there. From there, the next angle that I'm going to know about, you can either talk to me about angle 4 or angle 7. I'm going to talk to you about angle 4. We know that angle 4 is 101 degrees for a couple different reasons. Between X and 4, those are corresponding angles. Between 3 and 4, those are alternate interior angles. So you got a couple different ways that you can look at that to get to that answer. Oops, too far back. Then from there, we know that angle 7 is 101 degrees. A couple different reasons again here. Between 4 and 7 that you have right there, those are vertical. Between 7 and 3, those are corresponding. Between X and 7, those are alternate exterior angles. And on all those cases that we just talked about, they're all congruent in those cases. Okay? So from here now, we start working on angle 1, angle 2, and 5, and 6. And so for these, I talk about angle 1 next. How do I get that? Because between these two, I know that angle 1 must be 79 degrees. Reason being, because those two are a linear pair. Without that idea of a linear pair, this picture is a little bit difficult. You have to recognize that those two are a linear pair, and because they're a linear pair, they're supplementary. And then from there, you pretty much know what the rest of these angles are going to be. Measure of angle 2 has to be 79 degrees. You've got vertical angles there between 1 and 2, or you can talk about a linear pair between those two. Measure of angle 5 has to be 79 degrees, because you could talk about angle 2 and angle 5 being alternate interior, angle 1 and angle 5 being corresponding. Lots of reasons that you got there that work for you. You have a linear pair between 4 and 5. You have a linear pair between 5 and 7. And then last but not least, you have measure of angle 6 that is also 79 degrees. That looks weird. So 79 degrees. Because, well, you got linear pairs, you got vertical angles here, you've got corresponding between 2 and 6, you've got alternate exterior between 1 and 6. So there you go. I mean, you don't really have to talk about those reasons, but I like to talk about them because that's really why these angles have these measures. That's the reasoning behind it. Moving on. So from here, it wants to know what is the measure of angle A. Well, what do all the angles inside a triangle do? Add up to 180. So all you really need to do is go to your calculator, take 180 minus 22 minus 75, and that tells us our angle. So just jump into my calculator. 180 minus 22 minus 75 equals, and there it is, 83 degrees. Perfect. Moving on, and degrees, because I always like to put my label. I know it's there at the end, but that's just the math teacher and me. I provide my own labels. All right, so question 13. Moving right along. So it says, use Pythagorean theorem. What is the Pythagorean theorem? And that is a squared plus b squared equals c squared. And now it says to find the length, couple things. So if you look over here, there's definitely, well, no, there isn't a typo on this one. When you're finding the length, we don't talk about centimeters squared because that's area. Any label that is squared is area. Any label that is cubed is volume. And then up here, we don't even consider meters because it's not even in the problem. So when you're looking at this, make sure that you check the middle box because that's what they want. And all we got to do is run the Pythagorean theorem. Again, we get the option of rounding to 1 decimal place if we need to. So if you look over here, they're automatically telling you who's missing. We're missing A. Now the other thing that you need to know in class, remember I talked to you about this, that your A and your B are what we call the legs. And the legs make up that right angle that I just drew in right here. So these two sides that form that angle, this right angle that's right there, those are your legs. That's your A and your B. The other guy that's across from that, this is your hypotenuse. That's your C. Okay? Or in other words, when you look at your picture, the longest side is your C. So all we have to do is plug in. So A squared plus my B is 14 squared equal to my C, which is 27 squared. So I know what 14 squared is. That's 196. 27 squared, I have no clue, so I just need to go to my calculator. 27 squared is 729. So 729, and now I'm almost done because all I got to do is get the A squared by itself. So minus 196 minus 196. A squared is equal to, just go to my calculator, take that number we just found, minus 196. So 533. And how do I get rid of something squared? Square root. Now normally I would harp on you and say, please make sure you slap plus or minus in front of this. But because we are talking about length, we ignore the minus because we can't have negative length. It's impossible. So we just need to know what is the square root of 533. Square root 533 equals, and again, we get to round to 1 decimal place. So the 8 says, hey 0, go up 1. So that's 23.1. And of course, the label would be centimeters. And if you went up, that's what you'd be filling in this blank. 23.1. And that's your answer. Okay? So make sure that you pay attention to these. They're going to try and trip you up, and make sure that you're thinking about your label. Make sure that you plug in the Pythagorean theorem right. I can't tell you how many people will take the 14 and the 27 and they say that's A and B and then they look for C, which is wrong. Watch out what you're doing. All right, over here, this is all about similar triangles. Again, when we talk about similar triangles in class, it's all about making a proportion, and that proportion is all about being consistent. So we want to know what is the height of the tree. You have 2 triangles here. Hopefully you see them. One of your triangles is right here. It's this little itty bitty guy. And so if it helps, why don't you just pull that little triangle out? So this is a small triangle that is 6 feet by 14 feet. Okay? And then hopefully you see the larger triangle. I'll do that one in purple. There is the larger triangle. So we have this guy that is x by, in order to get this bottom length, you need to combine those two. Okay? So 182 plus 14 gives you 196 feet. Okay? So from here, again, similar triangles, and these triangles are similar, is all about making a proportion. You can either go from the small triangle to the big triangle, or you can go from the big triangle to the small triangle. It's your choice. I'm going to go from the small one, my blue one, to my big one, which is my purple. And all I'm going to do is match a side on the small one with a side on the large one. That's called being consistent. Okay? So a side on my small one that I can talk about is 6. The side that matches it on the large one is x. Because this side is oriented with that side, and they match up. I'm going to equal that to, because we're making a proportion, my bottom side of my small triangle with the bottom side of my large triangle. And now I'm ready to solve. It's all about looking at your two triangles and matching sides and making your proportion consistent. If I did big to small, then I could have x over 6 equal to 196 over 14. I'm still going to get the same answer. So remember, to solve proportions, we cross multiply. So we need to take 6 times 196. So 196 times 6 equals 1,176. So 1,176 equal to, cross multiply there, so that's 14 times x, which is 14x. To get x by itself, divide by 14. So x is equal to, well, let's jump to our calculator. We want to take that 1,176 divided by 14. And there's how tall the tree is. 84. But the question is, what's the label? If you've been paying attention, I've been writing it down. 84 feet. That's what we're looking for. So if we go back up, we've got choices here. So again, it's the middle choice because that's the one that has feet. And you'd put 84 in the blank. Okay? All right, so we are at question 14. After this one, only 10 more. So here it says all about perimeter. What does perimeter mean? Add it all up around the outside. So all you have to do is go to your calculator, take 17 plus 6 plus 20. So 17 plus 6, 17 plus 6 plus 20 equals 43. There you go. There's your answer. And then make sure that you select the correct label. It's all about feet. So again, it's in the middle, and that was 43 if I remember right. Right? 43? Let's take a look. Yep, 43. Man, there you go. Perimeter. Add up around the outside. Take a walk. Almost done. Again, perimeter. But if you notice, you're missing two sides. We're missing this long side, and we're missing this long side. It provided you enough information to figure it out if you just look at it. So to get the green side, what they wanted you to do is take this little piece right here, which represents the top half. Take this little piece right there that represents the bottom half of that side. And if you add those up, you get the total distance over here. So what is 5 plus 6? That's 11 feet. That's how long that side is. And then the same reasoning works for the next one. We're going to take this little bit right here, that's 5 feet. We're going to take this little bit that's right there, that's 7 feet. And if you add the 5 and 7 together, you get 12 feet for the full length at the bottom. Because those two horizontal lengths, when combined, make the length of the bottom. And now you have everything to find your perimeter. Again, all you're going to do is take a walk. So we're going to take 12 plus the 6 plus the 7 plus the 5 plus the 5 plus the 11, which brings us back to that piece. All I did was take a walk around my shape, starting at that corner. So 12 plus 6 plus 7 plus 5 plus 5 plus 11. So 12 plus 6 plus 5 plus 5 plus 7 plus 11. I believe that's all my numbers. Let me double check. Yeah, I just moved the 7 over down there by the 11. So, yep, I got everybody. Hit enter, and there's your perimeter. 46, and then what's the label? Well, if you look at the picture, everything's in feet. So we're down here at the last one, and it's 46 feet. Again, perimeter is just add up all the information around the outside. 17, find the sum of the measures of angles of an 8-sided polygon. So right here it's telling you that n is 8. And remember, I had you guys discover this formula in class, which the sum of all the measures of a polygon is n minus 2 times 180, because it's made up of all the triangles that make up the polygon. And inside an 8-sided polygon, an octagon, there are 6 triangles. Okay? Which explains the n minus 2, because 8 minus 2 is 6. And we know that all the angles inside a triangle add up to 180. So all we really need to do is take 180 times 6, and we have our answer. So 180 times 6. 1,080 degrees is what all those angles will add up to. 1,080 degrees. In an octagon, that's what all the interior angles will add up to. Okay? All right, moving on. So here we want you to find the area of a triangle. Again, we give you lots of information over here. You do not need everything. The area formula for a triangle is 1/2 base times height. Remember in class that I told you that the base is connected to the height at right angles. So there's only one right angle, it's right here. So that means the two sides that are connected to this are your base and your height. And because it's multiplication, it doesn't really matter which one. So what that tells us then up here is that the 5 is junk and the 14.4 is junk. All we need are the 1.2 and the 9.5. So area is going to equal 1/2 times your base is really the 9.5 and your height is really the 1.2. So we just multiply all that out and we get our answer. And now since we're talking about area, that means we need a label squared. So we're looking at the middle guy here because that's the one that has yards squared. So let's go to our calculator, take 1/2 times the 9.5 and the 1.2. 1/2 is 0.5, so 0.5 times, not minus, 9.5 times 1.2. I believe it's 9.5. Let me double check. Yep, 9.5. And again, I didn't delete the minus out. I don't know. I thought I hit delete. Oops. Delete. There we go. And then now we got our answer. 5.7 yards squared. And it wanted the exact answer, so I believe that's fine. I don't think they'll want the fraction, but if they did want the fraction, we could go to our calculator and type in alpha y equals, and then down here at number 4, we can change the fraction to a decimal, decimal to a fraction. So hit enter, and there it is, 57/10. Maybe they want that. I don't, I'd have to look. So 57/10 is also a valid answer for that. I mean, if you're looking for exact. Okay? We're getting there. All right, again, giving us another polygon to find the area of, and this one is the trapezoid. And again, area is all about label squared, so hopefully over here you automatically know which answer to start working with, and that's the middle one because that's the one that has squared. So area for a trapezoid, 1/2 B1 plus B2 times the height. And again, the B1, B2 mean bases, and as I said a moment ago, bases are attached to the right angle. So here's your right angle. That means these bases are attached, and the reason we call them B1 and B2 because there are two bases on a trapezoid, and they are the sides that are parallel. Hopefully you can look up here and see that, oh, this side is the one that's parallel to that one, so now you know who your bases are. So the 8.9 meters is junk, the 7.4 meters is junk. Now you have everyone you need. So area is equal to 1/2 B1 is 25 plus B2 is 14 and your height is 6. So all you have to do is multiply all that out, or in other words, take 1/2 times 39 times 6. So go to our calculator, 0.5 times 39 times 6, which is 117. And there we go, 117. Cool beans? I'm glad you agree. Question number 20. Now, in this one, make sure that you read very carefully because there are 4 parts to this, okay? Some of the parts, they want you to keep it exact. Other parts, you will be rounding, just like what we did in class. And when they say keep it exact, that means they want pi in the answer, okay? So we are finding circumference first. Hopefully you can remember that circumference is equal to pi d or 2 pi r. So if we look over here, what do we have? This 4 yards represents the diameter, okay? So circumference is pretty easy. Just use that pi d right here. So what is our circumference? Well, it's going to be exact 4 pi. And so over here, since circumference, another name for it is perimeter. So that means we're looking for a label that is not squared or cubed. So the top one is what we want to deal with. And then all you got to do in the blank is write 4 pi. And that is your circumference. Down below, it wants you to round. So that just means go into the calculator and take 4 times pi. So we go to our calculator. 4, your pi button is above the exponent key, the caret key right over here. So hit second caret, hit enter. And I believe it wants 1 decimal place, if I read correctly. Nearest tenth, and that is 1 decimal place. So the 6 says, hey 5, round up. So we want 12.6. And again, make sure the labels match. 12.6. Down below, now instead of circumference, we're looking for area. Okay? Area formula, there's only one. Pi r squared. So up here, since we know the diameter, to get the radius, you need to take the diameter divided by 2. So the radius is equal to 4 divided by 2, which is 2. So now we know what to do. Plug it in. Pi 2 squared, which gives us 4 pi again. And because we are talking area, that means we need a label that is squared. So here, in both of our answers down here, we're dealing with the middle part. And you actually already know the answers for these. The exact one is 4 pi. And then just stealing the 12.6 up above will be the rounded to the nearest tenth answer. There you go. You will have 4 answers to this. Again, just like the homework, we want exact and we want rounded. So make sure that you read carefully and know which one is which, and which one you're doing circumference and which one you're doing area on. All right, starting to get into these shapes. Again, here, this is now volume. So we're looking at the volume of a prism. So if you remember in class, I told you the volume formula was big B times H. But since this is a nice shape, it is actually all 6s. So this is that special prism, which is the cube. So we can easily find the volume by just taking S cubed. And since this is volume, we are looking at answers that have a label that is cubed, which means we're working with the last choice. So all we need to do to solve this is to plug in a 6 and cube it. So 6 cubed, I believe it's 216, but let me double check. 6 cubed, 216. So in the blank over here goes 216. A lot of this, guys, again, this test is all about, you know, using fractions and multiplying and then plugging into formulas and stuff like that. Okay, you guys got this. Plug and chug. 22, again, a lot like what we just did a couple minutes ago, but this time it's about a cylinder, and we want to be exact and we want to be rounded. So the volume formula for a cylinder, if you don't remember, it's a lot like the prism formula, that big BH, but our base is actually a circle, which is why we can plug in the area formula for a circle. So the volume comes from pi r squared h, because the base is a circle, and that's the area formula for a circle. So all we got to do is plug and chug. They give you 2 numbers up here. Here's the r, there's the h. Run with it. B equals pi. Your r is 8. We're going to square it, and then we're going to multiply that by 11. So again, we want to be exact. So I'm just going to go to my calculator. 8 squared times 11. So we're going to have 704 pi. And since, again, it's all about volume, so look for those answers that are cubed. So we know that we're going to be working with that one and that one. So up here, this is the exact, so that's 704 pi. To get the answer down below, and again, down here, we're going to round to the nearest whole number. All we need to do is take 704 times pi. So go back to our calculator and just say times second exponent, which gives us pi, and there it is. So nearest whole number, the 6 says, hey 1, go up. So 2,212 is our answer. 2,212. All right. Keep trucking on along. So 23. All right, so they're going to give us a long list of items, and all we're doing is selecting either the millimeter, the meter, or the kilometer, okay? Again, some objects to think about. Millimeter, think like the size of a bee. Meter, think like kind of like a yard. Kilometer, think in miles, okay? And I'm going to abbreviate these. Millimeter is going to be mm. Meter is m. Kilometer, km. So that way I don't have to keep writing out all these words, okay, over and over again. So down here, is it a millimeter, meter, or kilometer? So a person's height, measure that in meters. The length of a football field, definitely going to be in meters, because think of it again as yards, okay? The length of a bee, oh, weird, millimeters. Hey, the distance from New York City to Washington, D.C., that's like in miles, so think kilometers. The perimeter of a house, again, it's not like a mile, so I'd talk meters. It's a lot kind of like a football field. The width of a human foot, I do it in millimeters because it's not that big. The length of a car, I talk about it in meters. The diameter of a screw, millimeters. The altitude of an airplane, kilometers. The width of a book, meters. Okay, and there you go. Or sorry, millimeters. Okay, nothing real crazy there. Again, millimeters, think small. Kilometers, think extremely long. And then meters fits right in between there. All right? Nothing crazy here. I believe on the test this is like a drag and drop. Drop these little phrases in where they go instead of writing them out. And I think with that we only got, oh, nope, two more. That was the last one. Okay, so again, selecting from milligram, gram, kilometer, and ton, determine the best unit of measure to express the weight of a dog. Okay, so if I have a dog that weighs a ton, that's a big dog. I'd be worried, and yeah, that's craziness. A kilogram, I want you to think about those are kind of like pounds. So that's like a kilogram. Grams, those are kind of like grams would be, less than a pound, like maybe, well, let me explain milligrams, and then grams fall somewhere between the pound and the milligrams. Milligrams are really, really small. Think like the weight of a pill that you would take for like headaches and stuff like that. Those are measured in milligrams, really, really small. So grams fall somewhere between the milligram and the pound. So again, we want to talk about the weight of a dog. So the one that is closest is going to be the kilogram, okay? Because kilograms is like pounds for us, okay? Milligram is way too small. A dog is not the size of like a pill that I would take for a headache. A ton is way too big. There's something wrong with that dog if it weighs a ton. And again, grams are just too small, okay? Another thing that I think about with grams is kind of like usually when you weigh ingredients, you think about those in grams. So there we go. And we only got one more. Last one. Here we are. All right, last question. And this one, you got about 3 steps to do to get through this. So it says a prescribed dosage of a drug is 12 milligrams per kilogram daily, meaning that 12 milligrams of the drug should be administered daily for each kilogram of a patient's weight. How many 400 milligram tablets should be given each day to a patient who weighs 174 pounds? Use the fact that 1 pound is about 0.45 kilograms. So, and down here also a very important piece is that we need to make sure that we round to the nearest whole number as needed. So here's what's going to happen. The first thing is our patient is in pounds. We need to get them into kilograms. So that's the first thing is we need to convert from pounds to kilograms. And again, they give us this fun little fact that 1 pound is equal to 0.45 kilograms. So it's just a conversion. So our patient is 174 pounds. We want to get them into kilograms. So again, this is just that multiplied by your unit fraction. And our unit fraction is what I circled up there. Pounds is going to go in the denominator because that's what we want to get rid of. Kilograms will go in the numerator because that's what we need. Okay? So we put the 1 down here in pounds. We put the 0.45 up here in kilograms because that's how the fraction is set up. So we just need to multiply. So we go to our calculator. We got 174 times 0.45. And that gives us 78.3 kilograms. So that's how much our patient weighs. 78.3 kilograms. Now, up here, with that first sentence, because I know many of you will want to work with the 400 milligram tablets, but we can't deal with that yet. We need this first sentence to help us out, because we got to give our patient 12 milligrams of our drug for every kilogram that person weighs. So the second step now is we need to know how many milligrams this patient needs. And this little fact that's right here is another unit fraction. So we need to convert kilograms to milligrams now with that conversion that they gave us. So we know our patient is 78.3 kilograms. We need to know how many milligrams this person needs of the drug. Again, we've got that unit fraction. We want kilograms in the denominator because we want to get rid of that. Milligrams is in the numerator. So the patient is going to get 12 milligrams per kilogram. And the per kilogram would mean that that's for every 1 kilogram. So this is what we need to deal with. We need to take the 78.3 times the 12. And that will tell me how many milligrams my patient needs. So times 12 equals 939.6 milligrams. 939.6 milligrams is what my patient needs. Now, last piece, that's where the 400 is going to come involved. Our tablets come in 400 milligrams. So I need to see how many tablets that 939.6, right? Yeah. How many of those 400 milligram tablets that should be, and we'll round accordingly. So step 3 is you're going to figure out the number of tablets. And all you have to do is take the 939.6 that we found, divide it by 400, because we got to see how many times 400 goes into that, and that's how many tablets we'll have. So when we go to our calculator, we're going to take that number there, the 939.6, divided by 400, and that gives us 2.349. 2.349. And since it says round to the nearest whole number, this patient will need 2 tablets, because the 3 says, hey, 2, stay the way you are. If that was a 0.5 and above, you would have rounded up to the next tablet. Okay? Normal rounding rules on this. And there you go. That's what this exam will look like. Yep, that was the last question. Enjoy. It's been fun. See you in class.